my game plan for today, I'm gonna like teach you like 5 million things right now in the notes. We might be taking notes and classwork together for the whole period. I might not give you the classwork. I might just delete it, but we're doing work in here. So if you notice the points for the notes today is a lot, like a lot of points for notes today, not your traditional 5 points. So I made that on purpose and just for this class because I'm thinking we're going to be taking notes for like the rest of the period. I'll give you like, okay, here, give you 2 minutes to do this problem. Okay, cool. What'd you guys get? Okay, awesome. Instead of giving you like, I don't know. I might change my mind and be like, nah, do the classwork. Go. I don't know. We'll see. Okay, so I want to know what is the area of the shaded region? What's the area of just this part right here? Okay, there are 2 pieces of information I need to give you. I need to give you the radius of the big circle, and I'm going to say that that is 15 inches. And the radius of the small circle is going to be 8. Okay? So this could be like a word problem where they say like this is a park and we're going to put grass in here and then the inside part is water. I want to know how much grass we need. We need how much grass we need. So grass is area. So you're going to find the area of the shaded region. So what you need to know is you basically need to find the area of the big circle and subtract the area of the small circle. So you're going to take the area of the big circle and subtract the area of the small circle. So that will leave me the blue area. Okay. So the area of the big circle would be the whole thing. And if I subtract the little part, that will just leave like the donut part, right? So in general, this is what you're going to do. You're going to take the area of the big circle and subtract it from the area of the small circle. So I'm going to find the area of the big one, subtract it by the small one. Okay? Do you want to do this the long way or the short way? There's a long way and then there's a short way. So area of the big circle. So the big one. Area of the big one. Well, area is equal to pi r squared. So 3.14 times my radius of my big one. So the radius of my big circle, my big ginormous circle is 15 squared. So let's do that. times 15 times 3.14. So this is the area of the big one of the big circle is equal to 706.5, right? So now the area of the small circle, which is the inner part, is 3.14 times 8 squared, because the radius is right here, 8 squared. So that would be 64 times 3.14. So 3.14 times 64. So our area of the small one is equal to 200.96. Cool. Now what do? I got to take the area of the big circle, 706.5, and subtract the small circle, which is 296. 706.5 minus 200.96. 505.54 inches squared would be the area, would be your final answer of the shaded part. Okay, so again, if you're given a problem and it's somewhat like a circle within a circle and they're asking you, okay, what is the area of the outer part, then you would just do the area of the big circle, the area of the small circle, subtract it, and that's what you end up with. Okay, so let's try another one like this. Let me, okay. So let's say I have the green circle. That's the big circle, the green circle. And then I have a small inside pink circle. Okay. And then I'm going to format the numbers a little bit different. So now this one's like level 2 because the green circle has, so the big one, what is the radius equal to of the big circle? It's not 15. 15 is from this to this. It's not 10 because 10 would be the radius of the pink one. So the pink has, the small one has a radius of 10, let's say centimeters. So what would be the radius of the big circle? Can anybody determine the radius of the big circle? What's a big circle? So if the radius of the small circle is 10, then the radius of the big circle has to be bigger. And the radius of the big circle is actually 25. We'll call it centimeters. I didn't label it. How is it 25? Well, from here to here, it's 10, right? From here to here is 15. So technically, I can add that 15 right there. So then that means from this center out, it would be 15. From here to here, it would be 25. But we broke it up. The 10 is from this part and the 15 is from this part. But let's say these two circles are the same. So the big circle is the 10 plus the 15. That gives you 25. All right, so now let's find the area of the shaded part. Okay, like the donut. Basically, we're finding the area of a donut, you know, because donuts, they get the center part cut out, right? Terrible, but they do. Okay, so you need to find the area of the big circle and then the area of the small circle and then subtract them. Okay, area of the big circle is, again, pi times r squared, so 3.14 times my radius of 25 squared. And then my small circle is 3.14 times 10 squared. All right, so do those with the calculator. Oh, and remember, if you check your classwork from yesterday and you did not get a 10, that means you made a mistake. And some of your mistakes, ladies and gentlemen, are like, whoa. Let's make sure we're not doing that ever again. Ever. So this is what I got. So the area of the big circle is 1,920. I'm sorry. Well, 1,962.5. The area of the small circle is 314. So that's 1,648.5 centimeters squared. Correct me if I'm wrong. Sometimes I make mistakes. Let me go grab some water. All right, how are we doing on this? Are we okay with this type of problems? Can I move on to something else that I wanted to show you? Okay. Next. Okay, next thing I want to show you is given area, what is R or D? As in what is radius, what is diameter? So hold on, let me no, actually I can find a good example to give you. Okay, so if I tell you that the area of the circle is 939.77 inches squared, I want to know, cool, what is the radius equal and what is the diameter equal of this circle? So, well, you know that area is equal to pi r squared, correct? So what you do, I know this information. I know area is 939.77 equals pi. I know what pi is, 3.14 times, I don't know what radius squared is. That's what I'm trying to solve for. So you work your magic, you solve. So here it's multiplication, so that means you're going to divide by 3.14, divide by 3.14, right? So I'm going to take 939.77 divided by 3.14 equals 299.29, I'm going to round it, is equal to r squared, right? Now, this is where it kind of gets complicated, but it's fine. How do you break up an r squared? I haven't taught you that yet. You can't add, subtract, multiply, or divide to break it up because it's an exponent. You can't divide by 2, right? Because you didn't, it's not 5. If it's 5 squared, it's not 5 times 2, right? It's 5 times 5 if it's 5 squared. So in order to break up a square, in order to break this up, like how do you solve it? Well, you need a scientific calculator. If you turn your calculator sideways on your phone, and it responds to you. Come on. Okay. If you turn your phone sideways, you will see a square root, a symbol that looks like this. It looks like a division sign, but it has this funny little line on the side of it. This is the square root. It's the opposite of squaring. So for example, if I take the square root of 25, it is equal to 5. If I take the square root of 100, it is equal to 10. It's the opposite of squaring. It's the opposite of squaring. So you know how we teach you, like, what's the opposite of adding? Subtracting. What's the opposite of dividing? Multiplying. And vice versa. Here, the opposite of 5 squared, which is 25, the opposite is to do the square root. The square root of 25 is 5. The square root of 100 is 10. You're going to be using these in next year, and if they give you these problems, you'll need them here. So in order to find for radius, what I have to do is I have to take the square root of r squared, the square root of this number. When I take the square root of r squared, I am left with just r. The square rooting part, it gets rid of the little 2. All right, so gonna type in this number, 299.29. Then I'm gonna find the square root, which is over here with the little 2 there. And my answer is 17.3. So my radius is equal to 17.3. Again, how did I do that? I'm left with r squared. So when I'm left with r squared, I take the square root. So I'm going to type in 299.29, and then I'm going to take the square root, which is on the iPhone, it's like over here. It's on the second column, third row. Take the square root, and I get 17.3. So that means that my radius is 17.3, and if I multiply it by 2, that tells me that my diameter is 34.6. So given the area, what is radius, what is diameter? Given area, you can also solve for circumference. You can do a lot. Are we okay? I rounded this because when you get 939.77 divided by 3.14, I rounded to the nearest tenth. The 9 tells the 8 to go up. So that's why I wrote 299.29, because if I'm going to round and I'm going to get rid of all of these numbers behind it, I look at that number and go, yo, 9. What are you going to tell me to do? Up or stay the same? The 9 tells the 8 to go up, so that's why it's 0.29. All right, let's try one more, and then we'll teach you something new. Okay, so the area is equal to 22.05 feet. I want to know what R is, and I want to know what D is. If you don't get these like on the map test, you will 100% get these in geometry and in high school. So even if it's not for Monday, and it's cool because I just taught you how to do square roots, which usually do appear on map because it's easy, but not everybody knows about square roots. Okay, so again, area is pi r squared. So now you're going to plug in the numbers that you know. Well, I know the area, 22.05 is equal to pi is 3.14 times radius squared. All right, so the first thing I have to do is to divide by 3.14. Divide by 3.14. 2205 divided by 3.14. 7.02. The 2 tells the 2 to stay the same, right? So I'm going to get rid of all of these numbers, and I just stay with this 2. I'm rounding to the nearest hundreds, right? All right, so then I'm left with r squared. So I'm going to take the square root, right? So to break up a square, you use a square root. It's the opposite. So when I do this, I'm left with r equals. And then I got to turn my phone, 7.02, look for the square root. Eeks, ugly number, but it's fine. 2.6. I'm going to round. What does the 9 tell the 4 to do? The 9 tells the 4 to go up, so it would be 2.65. That would be my radius. 2.65. 2.65 times 2, 5.3 feet. Then I could do circumference if I wanted to. It's fun. I like these because it's just like a mixture of like all these like different math stuff. Let me see. What else did I want to show you today? Okay, yeah. So like on your classwork that I may or may not have time to give you, you see how I started off giving you the area, and then here I wanted radius, diameter, circumference. Man, I was being mean. And then here it was the small circle, big circle, and I said what's the area of the shaded region. The last thing I'm going to show you today are called compound shapes. Find the area of the shaded. So they love giving you these problems because it's testing you on more than one shape. Like, do you remember how to find the area of a triangle? Do you? All right, so let's do a shape. Let's start off with a shape that looks like this. Okay. So let's say this is, I don't know what it is. And we need to find the area. Okay? And I have given you enough information to find the area. So what you do is you first figure out like, okay, what shapes am I dealing with? Okay, I'm dealing with the rectangle and I'm dealing with half a circle. So we need to find the area of the rectangle and then we need to find the area of the half circle. All right. So the area of a rectangle, this is why they love to give you these problems because they're testing you on like, well, do you even know how to find the area of a rectangle? And you're sitting there going like, of course I do. Well, do you? So the area of a rectangle is just like length times width, right? So length times width. So that would give me 8 times 10. So it would be 80 inches squared. So the area is 80 inches squared, right? Pretty simple. Now the circle, area of a circle, but it's half a circle. So you're going to find the area of the whole circle and then divide it by 2. Why? Because it's half a circle, right? That's how they trick you. You'll do like the area of the circle, like, yeah, I know how to do the area of the circle, woohoo! And then you forget to divide by 2 because it's half a circle. So careful. So for the circle, I'm going to do pi times radius squared and then divide it by 2, right? Why do I divide it by 2? Because it's half a circle. That's it, just because it's half a circle. Cool. Yikes. What's the radius equal to? What would be the radius? Yep, 4. Because if you have a rectangle, 8 is over here, right? So 8 represents this whole line. Well, 8 would actually be your diameter because it would be the whole line. But if I'm just looking for the radius, it would be half of your 8, so it would be 4. They love to hide the numbers. So it would be 3.14 times 4 squared, all divided by 2. Don't think that this 2 and these 2 can be eliminated. Oh God, no. All right, 4 squared, 3.14 times 16 divided by 2. 4 squared is 16. So 3.14 times 16 divided by 2. So the area of that half circle is equal to 25.12. So the area of my rectangle is 80 inches squared. The area of my half circle is 25.12 inches squared. So I'm going to add those up. So 80 plus 25.12, 12, 5, 10. So my total area is 105.12 inches squared. Guys got that? Following along? Easy stuff. I mean, I would think today would be maybe the first day or maybe second day that it's like real hard math at a pretty fast speed. Or, yeah. Okay, let's do a triangle with, how do they look like? Okay. Wait, sorry. Okay, I'm gonna copy this. Okay, I'm gonna copy that. Is that? Oh wait, oh gosh. It's a half a circle. That's what kind of, okay, never mind. Oh my gosh, what is happening to me? Okay, I needed to see it. I couldn't memorize it. Okay, there we go. Sorry, half a circle. Kind of looks like Jack in the Box. Ignore that. Okay, so I want to know the area. I want to know the area of this shape. Okay, so I have two shapes. I have a triangle and I have half a circle, right? And I want to find the area. Well, again, they're going to test you and see like, well, do you remember how to find the area of a triangle? Area is equal to base times height divided by 2. Area of a circle is pi r squared, right? But because it's half a circle, I'm going to cut it in half because it's half a circle, so I'm going to cut it in half. Your traditional area of a circle has no divide by 2, right? All right. I know it looks hard. I 100% agree. But you actually have the information in your brain and you have the capability of doing it. It's just a matter of like fishing it out of your brain and realizing like, okay, it looks hard, totally like a lot of math involved, but it's you've done this before. You've done the area of a triangle. You've done the area of a circle. It's just putting it all together. So don't fear it. So the base of my triangle is 4. The height of my triangle is 10 divided by 2. So 4 times 10 is 40 divided by 2 is 20. So the area of my triangle is 20. Now I'm going to do the area of my half circle. 3.14 times, I use the same number. 4 squared divided by 2, right? This represents the radius, right? So it would be 3.14 times 16 divided by 2. So my area would be equal to whatever I got last time, right? 2512, 2512. I knew that because literally it was the same problem we just did. So now we're going to add them. 20 plus 25.12 is going to give you 12, 5, 4. So this would be your total area. Let's say feet squared. They'll usually write the units. So this is called compound area or complex area or complex figures. I call it compound because you have two shapes that are mushed together. They're make a different shape, so they're compound together. And then you'll find the total area. Okay, so the total area here would be 45.12. That's what I was going to show you, you see? Like this problem here, you would find the area of the rectangle, then you would find the area of the circle, here the triangle, and the whole circle there. The way they trick you is they might not give you the radius, they might give you the diameter, so you just have to be careful. Like all of these, they give you the radius, so there's no like tricks there. But what am I going to do? It just depends on what they give you. All right. I'm going to remind you that I did post like a lot of videos on Canvas of things that I did not cover. One of the things I did not cover, I will cover later, is volume of a three-dimensional shape. So here's my rectangular prism. So volume is equal to length times width times height. So it would be 5 times 6 times 8. This is the height. So the volume, the only difference with volume is you have a height because it's three-dimensional. And if this was inches, so we would multiply this. It's 240. So volume is equal to 240 inches cubed. So when you have volume, it's actually inches cubed because, I mean, shorthand, it's just because you multiply three numbers. It's inches cubed. Area is squared. Volume is cubed. Volume is cubed. Area is squared. Volume is pretty easy. All you have to do is length times width times height of a rectangular prism. Triangular prisms are a little bit different. Something else I have not taught you, but I will after. You can watch the video. Is called, surface area. Surface area is dealing with, again, three-dimensional figures. And I'll show you how to draw these when we have more time. So surface area is the area of each side, well, the sum of the area of each side. That doesn't make any sense, does it? The sum of the area of each side. So area of each side added together. Yeah, sure. Area of each side added together. If you have a box, if you get like Amazon deliveries, you have a box, right? You get a box delivered to your house. How many sides does a box have? It has a top, a bottom, a front, a back, a left, and a right. So this has 6 sides, right? So you would find the area of each of the sides and add it together, kind of like wrapping paper. And that's called surface area. So surface area is how much wrapping paper do you need to cover the whole box? You would find the area of the top plus the area of the bottom plus the area of the front plus the area of the back plus the area of the left and right. If you want a detailed explanation, check out that YouTube video that is linked up in Canvas already. Something else that we will cover after the map test will be probability. Probability of if I have a bag full of, let's say I have these markers, right here, right in front of you. Look right there. You can listen. You can listen. You can listen. If I write something down, then you're going to write it down. Actually, yeah, I'm going to write this down. Okay, I have this. Okay? I have this in a bag. So here's my container. I have a red, and a blue marker, right? A red, and a blue. Super easy. What's the probability of capital P stands for probability? What's the probability of selecting a red marker from my bag? What's the probability of selecting a red marker? That would be 2 out of 3, right? And you write probability as a fraction or as a decimal, usually as a fraction though. Probability would be 2 out of 3, okay? Then it gets kind of harder. What's the probability of red and then red without replacing? So what's the probability of getting red on the first draw and then red on the second draw without replacing? Yes, Jocelyn, I remember too. So the probability of red would be on the first draw is 2 out of 3. But then on the second draw, if I draw a red and I don't put it back, I'm at 1/2. Right? So the first draw, I have 2 out of 3 reds. But then on the second draw, like I pick one, I got red, I throw it away. I don't replace it without replacing. I now have only 1/2 left. 1 out of 2 are reds. We multiply this together, we get 2 over 6, which is equal to 1/3. The probability of me choosing red on the first draw and then not putting that red back, I gave it to another teacher. Now what's the probability of me going back in there and choosing a red again? Well, my probabilities drop down to 1/2 on the second draw. Together, so if they're asking like and, when you see the word and in probability, you're going to be multiplying. So the probability drops down to 1/2 from 2/3 to 1/2. So the total probability of doing a red and then a red without replacing would be 1/3. So in probability, there is something called with or without replacing. Do you put the marble back? Or if it's like, I have a bag of candy, I eat one candy each day. Well, that changes your probability each day because each day you're taking one out and it drops your probability. Okay? It's just so much stuff I want to like cram in your brain.